Hello everyone, this is Greg from ChemCore. In this video, we're going to be discussing the carbonyls, esters, amides, and carboxylic acids worksheet. If you haven't checked the topic video for this video, make sure to check that out. It's in the description below. Also, this is kind of the fourth or fifth video on the functional groups unit. If you haven't watched any of those previous videos, I really suggest you do. We're not only in this worksheet, I'm not only going to be testing you on esters, amides, and carboxylic acids. I'll also be asking you about concepts of the previous functional groups, the ones that you should already be familiar with. And I think it's useless kind of just focusing on three functional groups. I think combining them all and making sure everything is completely clear and you're not mistaking two things is really useful. Now, for most of these functional groups, I really like tricks and stuff. And in the video, you can kind of tell that I don't really have any tricks for remembering these functional groups. It really is just practice. But from my experience, students often mistake esters and ethers. They're kind of similar words. And so you might think ester, but it's actually an ether, and you kind of mistake the two words. And so my little thing is that ester says ooh. Now, I really have kind of no idea if Esther says ooh has helped anybody except for me. I just remember it helping me because I always forgot the difference between esters and ethers. And knowing that Esther says ooh, those kind of two O's, I know that Esther is the one that has the two O's. And ether is the one that's kind of in the middle of the carbon chain. Again, you should already have experience differentiating ethers. This is in a previous video, actually 2 videos ago, we talked about ethers. And so if you haven't, make sure to go watch that video. There's also a bunch of worksheets with that as well. In these problems, we're just going to be identifying the functional groups present. Maybe there's more than one, maybe there's just one. And then we're just going to explain and kind of go through how you can differentiate between them. And so the first problem, I really see an oxygen and another oxygen. And so I know it's either an ester or a carboxylic acid. Once you see those oohs, it could only be one of the two. And so this additional R group right over here, it's actually a methyl in this case, is actually telling me that it's an ester. And so we know that this is an ester for sure. The next one is actually a perfect example. We again have these two oxygens, and so you know it's either an ester or carboxylic acid. And well, carboxylic acids have that OH. And so I know that this is a carboxylic acid. The next one is kind of, different. In this case, we have that oxygen, but that carbonyl carbon, the one that holds that carbonyl, is actually also connected to a nitrogen. And so this makes it an amide. Now, in some textbooks or courses, we kind of discuss amides grouped together with amines and nitriles because they all contain nitrogen. I feel like it's easier just to put them in the carbonyls section because it does contain a carbonyl. But this will really fuse very nicely with our future, with our next video where we discuss the nitrogen-containing compounds. And so this is one of them. It's kind of a Venn diagram. It's in the carbonyls category as well as the nitrogen-containing compounds as well. In the next structure, I see this carbonyl with nothing else going around. So I know that it's either an aldehyde or a ketone. Now, also, I see that it's at the end of a carbon chain. And so I know that it has to be an aldehyde. In the next problem, I again see a carbonyl with nothing else going around it. And so again, I know that it's either an aldehyde or a ketone. The thing that's telling me, though, is, well, it's surrounded by carbons from both sides. It's in the middle of the carbon chain. And so if you remember, the key goes in the middle of the lock. This is a ketone. The next problem, I see a hydrocarbon, right? Nothing else going around but carbon and hydrogen. I see this triple bond, and so I know that it is an alkyne. In the next problem, I see 2 double bonds. Now, usually in some courses, we would call this a diene. I'm not going to. This is something that we're going to discuss in the future. I'm just going to call it an alkene for our purposes, although I don't think that your course or professors will go and give you this example. But just realize that it's an alkene, yes, but there's 2 of them, right? And so we call it di or 2 enes, right? Diene. The next problem, I see that oxygen inserted in the middle of the carbon chain. So I know that this is an ether, right? This is where that ester says, ooh, really comes in handy because you will not mistake this for an ester and you're not going to accidentally write ester. And the next problem, I see this hydroxyl that is bonded to an sp3 hybridized carbon. So I know this is an alcohol. Next problem, similar example, I see a halogen bonded to an sp3 hybridized carbon, so I know that it's an alkyl halide. In the next problems on this page, I see two oxygens, and so I know this is either an ester or a carboxylic acid, but this R group connected to that second oxygen really tells me that it's an ester. Now in the next one, kind of interesting, right? I definitely see these two oxygens, and one of them is a hydroxyl, and so I know that this part of it is definitely carboxylic acid. But if you just wrote carboxylic acid, you'd be wrong. Remember, I need you guys to be like almost as soon as you see this benzene, you need shots need to be firing off in your head. Benzene can be two functional groups, either a benzyl group or a phenyl group. And what you should know is that phenyl groups are connected to a different functional group, right? Or that R group. And then benzyl groups are connected to a free carbon. This is definitely not a free carbon. And so it's also contains a phenyl functional group. In the next problem, I see this oxygen that is, a carbonyl, but the carbonyl carbon is directly connected to another nitrogen. Now, although it's a really small molecule and it only contains one carbon, it's still an amide, right? It's still an amide. There is nothing telling me that it can't be, right? Just because it has one carbon, so what? The next problem, I see this oxygen that is double bonded to a carbon. And so I know that it's a carbonyl. There's nothing else going on around it. And it's also at the end of the carbon chain. And so I know that it's an aldehyde. In the last problems of this worksheet, I see a carbonyl, right? Nothing else around it. And so I know that it's either an aldehyde or a ketone. It is surrounded by carbons. It's in the middle of the chain. And so I know that it is a ketone. Next problem, I see this double bond. Nothing else going on, right? Just a hydrocarbon. And so I know that it's an alkene. Now in this problem, kind of interesting molecule, you might be confused, but it's okay. We see these two oxygens that are kind of inserted into this carbon chain. Just because there are two of them doesn't mean it's a new functional group, right? We just have two ether functional groups. They're both ether functional groups. And so we're just going to write ether for our purposes. The next problem, I see this halogen, this bromine, that is connected to an sp3 hybridized carbon. And so I know that it's an alkyl halide. And in the last two problems, I see this hydroxyl bonded to an sp3 hybridized carbon. And so I know that it's an alcohol. And finally, the last problem, I see this triple bond. It's a hydrocarbon, right? Nothing else going on in the molecule. And so I know that it's an alkyne. That concludes the video on carbonyls, esters, amides, and carboxylic acids. If you feel unfamiliar with these concepts, go back to the topic videos that describe this kind of section, as well as the previous carbonyls that we learned last time, like aldehydes and ketones, the functional groups that we learned even before that, so alcohols, alkyl halides, and ethers, and the hydrocarbon functional groups, so alkanes, alkenes, and alkynes. And I'll see you guys in the next video.